Welcome back to Physical Science Online edition. So today, as I warned in my task 1, we're going to do task 2, which is to make a graphic organizer about these heating and cooling curves to help you out with understanding and to have it all in one spot. My suggestion, since we're going to do a lot of labeling and this is super important, is in your notebook, like turn it sideways and actually draw this whole thing, make it take up a whole page sideways. Over my shoulder here is what you should start with. So you can even start drawing this as I'm talking, or you can pause the video. So we have our heating and cooling graph, which has temperature on the y-axis in Celsius and time on the x-axis in minutes. Always include your chickens. Always label stuff on your graphs. Technically, I should probably have a graph title up here too, but since I'm just doing this for the video's sake, I did not. And then we have a heating curve, if you want to draw a little line down the center of this. Heating curve, followed by a cooling curve. Heating, cooling. And I purposely did not add numbers to the temperature over here because this should apply to any substance ever. So it doesn't matter what temperature numbers you run over here, what substance you look at, it should work every time. And it doesn't matter if I'm on my heating or my cooling curve, my bottom temperature, my lowest temperature on either side is actually going to be a solid every time. So I can add in solid for my lowest temperature. Then my next one up, my next highest temperature, or my middle temperature, because we have 3 different horizontal points, if you remember from the first notes, is going to be my liquid. And hopefully you guessed it, the highest temperature. If you have 3 phases, the highest one is going to be the gas. Then these horizontal lines in between the phases are when we have those phase changes, when energy is going into or out of those bonds to break them or form them. So we have these little plateaus, and each one has actually the name of a phase change. So if I go from solid to liquid, let's put this in water terms. So if I go from ice to melted water, oh, I gave the answer, sorry. That's called melting. If I go from liquid water to a gas, hopefully you learned in the reading that is not called boiling. Boiling is when it happens rapidly. It's a very special type of evaporation. Then on my cooling side, as I go back down in temperature, if I go from gas to liquid, this happens on hot summer days. If you have a glass of ice water, you get condensation on the outside. And if you go from liquid water, stick it in the freezer, down to your solid water, the name for that is freezing because it's in the freezer. And then one more thing to add, there is a special circumstance. It doesn't happen with very many substances, but sometimes you can skip the liquid phase because a substance doesn't like being a liquid. And you can go straight from solid to gas. That's called sublimation. Or you can go straight from gas to solid. And that's called deposition. If those are a little hard to read, make sure you look them up in your textbook. The orange isn't showing up as good as I hoped, but I think you get the gist of it. This is a great graphic to memorize. And actually, this graphic would cover all of BP2. You just took your BP1 quiz. This graphic basically covers all of BP2. And now we're just going to do some labs and some other activities to make sure that we're all on the same page with this. Okay, so those are your 2 videos for today. Have a good rest of your Friday, and I will see you on Monday. I'm out, if I can figure out how to turn this off. There we go.